Let's go to part 4, solving the following trig inequalities. A. 2 cosine x over 2 plus 1 less than or equal to 0. Since this is a linear inequality, we need to isolate cosine x over 2. Therefore, cross the river, change sign. 2 cosine x over 2 less than or equal to -1. Then we divide it by 2 both sides. The rule for linear inequality is mommy, daddy, nanny. When you multiply or divide it by negative number, you need to switch the symbol. Divided by positive 2 both sides, symbol stay. So we got cosine x over 2 less than or equal to -1/2. After this, the next step will be solving the equation cosine x over 2 equals -1/2. We know 1/2 less than square root 2 over 2 less than square root 3 over 2. When opposite side is 1/2, the reference angle is 30 degrees, which is the pi over 6. If for opposite side is square root 2 over 2, the reference angle is 45 degrees, which is pi over 4. For opposite side, square root 3 over 2, reference angle is 60 degrees, which is pi over 3. We do know cosine is adjacent 1/2, which means this opposite side is square root 3 over 2. So we can figure out the reference angle is pi over 3. -1/2, which is less than 0. All students take calculus. Go to second and the third quadrant. Second quadrant is 2 pi over 3. Third quadrant is 4 pi over 3. Since domain is between 0 and 6 pi, we need to use all solutions format to figure out all angles between 0 and 6 pi. So we have x over 2 equals 2 pi over 3 plus 2k pi. X over 2 equals 4 pi over 3 plus 2k pi. K is all integers. Get the same denominator, 2 pi plus 6k pi. X over 2 equals 2 pi plus 6k pi over 3. Then we times 2 both sides. X equals 4 pi plus 12k pi over 3. X over 2 equals 4 pi plus 6k pi over 3. Times 2 both sides, we got 8 pi plus 12k pi over 3. Remember, the domain is between 0 and 6 pi. When k equals 0, we got 4 pi over 3. K equals 1. We got 16 pi over 3. For this 6 pi, we can change it into 18 pi over 3. So 16 pi over 3 still in this domain. K equals 2. It's out of domain, so cross out. For this solution, k equals 0, we got 8 pi over 3. K equals 1, we got 20 pi over 3. It's out of domain. So we found 3 solutions to this equation. Second step, we need to sketch the graph y equals cosine x over 2 and y equals -1/2. Then we can solve these inequalities. When you sketch the graph of a trig function, we will use this NPAP. No people are passing to remember this rule. N means new origin. For y equals cosine x over 2. Since no horizontal or vertical translation, we got new origin still 0, 0. Period equals 2 pi over the coefficient of this x, which is 1 over 2. We got 4 pi. A means amplitude. It's 1. Pattern. Y equals a positive cosine pattern. We need this 5 key points. This is the midline. Midline is y equals 0. It's the y coordinate of this new origin. Now let's sketch this graph. X, Y, origin. We will label period first. 4 pi. Half, 2 pi. Half again is pi. From this origin, look at the amplitude. Go up 1, down 1. Then you can draw this pattern. 1, 2, 3, 4, 5. We need to keep going because the domain is between 0 and 6 pi. This is 6 pi. Go down and down. Then sketch this graph. Then we need to draw y equals -1/2. This is -1. This is -1/2. Just estimate. Y equals -1/2. We are solving cosine x over 2 less than or equal to -1/2. Use a happy face and angry face to remember. Greater than or less than, open circle for the number line, and a dotted line for y greater than or less than mx plus b. Greater than or equal to, less than or equal to is a closed circle. Solid line. Solid line is for y greater than or equal to or less than or equal to mx plus b. For interval, open circle for open parentheses, close the circle for bracket. Since we have less than or equal to, close the circle for intersections. Less than or equal to -1/2, which means below y equals -1/2. This will be the solution. But how to label these intersections? Go back here. So this is 4 pi over 3, 8 pi over 3, 16 pi over 3. We will write down the solution like this, bracket 4 pi over 3 to 8 pi over 3. Union 16 pi over 3 to 6 pi.